great points for a very smooth change over there. That transition was seamless.
So this is my topic, discussion on the value of geotech images in urban planning and design. Currently, people are trying to utilize different types of big data in planning domain. My research question then comes to an illustration that millions of geotech images are sharing over the internet every day, considered as an important component of global big data. Is it possible to take use of geotech images for urban planning or design purpose? If it can be used in planning domain, how? And what are the limitations of using this technique? In order to solve the problem, I'll first practically review some precedent research outcomes and then propose three possible applications of geotech images related to urban issues with case studies, and finally discuss the limitation of using this geotech images. Because of the limited time, I'll only explain my favorite phrasing outcome. And this is the origin destination network among the top 10 cities to city estimated flow of visitors. For example, following the rebound between London and New York.
Sorry, guys.
On the London side, it represents people living in London who visit and take photos in New York City. And the result of this study can be used to identify what has to be enhanced in cities and what it can be appropriate to increase user service for foreign investors. After reviewing some of the precedent applications, here comes the applications proposed by myself. So when we're talking about the urban density, it is not only the building density or the population density, but also some active densities, such as here I mentioned the tourist density. This application is used to identify the places with high tourist density. The first case study on Beijing is used to test the accuracy of using geotech images density to represent the visitor volume of specific places. The hotspots are highly correlated to the real statistical data. It can be concluded that all the density hotspots have large tourist flows, but inversely may not correct. For example, some places such as the shopping centers or bars may actually have large numbers of tourists, but people are not intending to take photos there. So especially for my data source from the Panorama, which mainly focus on the signs. As the first case shows that the tourists may be represented by the geotech images, the second case study on Barcelona, trying to develop an application of utilizing this relationship. Here is the coverage of geotech images by 500-meter catchment area of subway stations to determine the subway access to popular tourist destinations. The result comes that 57% of the photos are covered by the buffer. If we have a look at the clusters which are not covered in the buffer, for example here, the Camp Nou is a large stadium for about 900,000 people. So we may notice that there were 5 subway stations around there. So it is good to evacuate people after the big matches. Overall, we may consider that the public transport service in Barcelona to the popular tourist destinations is quite good. And this one is New York Central Park. From the map, we can identify that the southern part of the park is mainly for tourist purpose because the density of geotech images is very high. And for the northern part, it's mainly for maybe the local recreation purpose. And the second application is to identify the risk points in project management. A stampede happened on the 2015 New Year's Eve on the Mount Shanghai, which caused 36,049 injured, has raised a big concern in crowd management in China. As the geotech image is able to represent tourist density, is it possible to take use of these images in assisting crowd management? If we have look at this case study on the Bund in Shanghai, here is here is exactly where the stampede happened. From this map, the stampede only happened at this location rather than anywhere else. It's absolutely not a coincidence. So by using this technology, we may do something to prevent this kind of accident from happening. The next study took place on the similar high-density area on the Amnion Star in Hong Kong. Then based on the density map, we may design the evacuate route for big events. This is the third one. I'll try to predict the frequent safe haven places. When taking photos, photographers may focus on the scene or their shooting devices, but not their pockets. And that's maybe a chance for thieves to commit a crime, especially in crowded areas. So, is there any correlation between geotech images and the frequent safe haven places? If so, the potential high-risk areas of safe crimes can be predicted. Here I took the case study on San Francisco, and this is the result. No significant correlation can be identified on this map. Several reasons may be able to explain this result, but I think most significantly should be the crime rate is always closely related to some social factors. For instance, the relatively low average household income or high unemployment rate. So this application actually failed. From the three case studies, I conclude three limitations of using geotech images. Firstly, the representativeness. It can represent its photographers, but what else can it actually represent is still a question. Also, the comprehensiveness. As I mentioned in the first study in Beijing, so some tourists may not comprehensively represent by the images. And lastly, the correlation with urban planning design. When I designed the case studies, I found it's really difficult to correlate these two things together. Finally, I got the conclusion. I think geotech images may have potential in assisting urban planning and the design issues, but not only in limited aspects. And in a larger context, the use of big data in planning domain should be carefully determined before these new techniques are proven to be effective. Lastly, I believe traditional methods in building cities should never entirely be replaced by the new ones. But the new and the old should finally converge and help people build their cities.
Wow, that's so impressive for such a small, short-term project, and just amazing use of primary data. It's just amazing what you can do.
Yeah, I didn't dig very deeper, but general analyze.
Yeah.
It's more like feasibility study. What can the staff really do?
You're right. I mean, you could unpick those findings in such detail. It's okay that obviously didn't have a chance to do that, but it's pretty amazing. Were there any questions or comments, Nicole?
Well, how did you match up to where did you get the data sources to match up with? So you used the Boston repository for the geotag images, but how did you get the data sources from the other cities to do your analysis?
It's just a database by another research group, and
by another research group.
Yeah.
Wow.
Yeah, it's open source. Yeah, all the data.
From the same source, you're able to use the same other data repository, or did you have to use lots of different ones?
Yes, I used the data source from a research group in MIT. Yeah, but all the data source of geotech images I use from the Panorama is open source.
Let's say for the prime stuff, for instance, where did you get that data from?
It's from the U.S. government organization, the website. They record. They record the files.
And do the correlation.
Yeah.
Awesome. Right on. Let's move on, though. Jiaming.